Hello everyone, I hope you guys are doing well, and I hope that you have survived your first day of online learning. So I created this review for you guys. Originally it was supposed to be a game, and so I'm kind of bummed because we were going to have stations and things like that, but I made it into a review, so it does have a lot of questions, but it's going to be really helpful to study for the quiz on Thursday. So I'm going to just go through, because we haven't seen this in a while, and it's been before spring break. So I want to go through some of these questions. I'm probably just going to pick out about one from each section and go through them, and then you guys can go and finish the rest of them. But remember, if you guys do have questions, that I am here. So if you just email me and say, hey, can you work through number 5 on the review? I will make a short video, 2 minutes long, and I'll send it to you, and then I'll post it on Canvas. So if you ask it, then that's really helping everyone else, and then they can watch it as well. And maybe it'll combat some of the same questions that I get. So it'll really benefit everyone else. So as you're working through this, please ask questions. I'm available by email today. So I'm going to start with this first one, and this is from 8.1, the exponent rules. And so I'm going to look at number 3. And remember, when you have a negative exponent, that will either flip the fraction, or it brings something that's on the top to the bottom to the top. We don't ever want to leave our answer in negative exponents. So something that you could do is you could distribute the -2, or what I'm going to do with this fraction is I'm going to write it as 3/4 squared. And then for the next one, I'm going to write it as 4/3 to the positive 1 power. So what that does is, if you flip the fraction, I know it's going to go to both the top and the bottom because of the distributive property. If I just go ahead and flip it first, then I can change that exponent to be positive. So then from there, it's going to be 9/16 times 4/3. And with that, I'm going to multiply. But I can actually, before I multiply, I can simplify first. So the 4 and the 16 can be 1 and 4. 9 and 3 can be 3 and 1. So my final answer would just be 3/4. This was also a part of 8.1. This was 8.1b. And 1 through 6, it's solving for x. And if you have a rational exponent, remember, you want to raise that to the reciprocal power to solve for x. So 3 through 6 are problems that we have done in previous chapters as well. So I'm going to let you guys do those. You may need to look back at your notes for number 5, because this is the kind of question where you're going to have to FOIL with the square root of x. And so I don't want to spoil that one for you, because I know that you guys are able to look at your notes and get that one done. So I'm going to look at, I'll try number 2 for you guys. So think about it as PEMDAS backwards. So I'm going to add, subtract first, then multiply, divide, then exponents, and then parentheses last. So I'm going to subtract 5 first. So 3x plus 2 to the 3/2. Subtract the 5. And so that leaves me with 27. In order to get rid of the 3/2 power, I'm going to raise it to the 2/3. So then these will cancel and just become 1. So on the left, that leaves me with 3x plus 2. On the right, when I'm doing a rational exponent, I'm going to do the denominator first. So I want to take the cube root of 27, which is 3, and then 3 squared would be 9. From there, 3x equals 7, x equals 7 over 3. Remember with these kind of problems that you will typically get one answer and you don't have to check that. It's 4, 3 through 6 if you get two answers. If you have to factor it and solve, or quadratic formula and solve or something, then that's when you have to check your answers and see if you have any extraneous solutions. So for the graphing, remember that we have two different types. We have exponential and then we have logarithmic. So I tried to kind of separate them with exponential first and then logarithmic, but on the quiz they could be all jumbled together. So what I would do is for every single one, I would go ahead and draw the original, and we had some practice with this beforehand, but some, I guess, reminders about this section is if you have an exponential where the b, or your base value, is greater than 1, then it's going to be a growth, which means it's going to be going up like that. Oops. And then if you have a number from 0 to 1, then it's a decay and it's going to be looking like this, which that's not a beautiful picture, but my suggestion is that you draw the original and then do the transformations from there. So I see two of them that have a negative x, and that's something that we kind of struggled with before, so I'm going to do number 2 with you guys. And it's an e. Remember, e is the same thing as 2.7, so we treat the original just like this. Like it's still a growth, it's going up, it's bigger than 1. Then I'm going to look at the transformations. This negative x means that it flips the y-axis, and then I'm going to go up 2. So I flip the y-axis, and if you need to, label your x and y. Flip the y-axis and then go up 2. So I will be up here. Well, I don't know why I'm making a dashed line. Just like that. And I will have a horizontal asymptote, and it's always at the last number. This is what got us on the quiz, but it's at y equals 2. And then for my domain, it's always all real numbers. I don't know if this is showing up. Let me redraw this. Didn't look like it was showing up on the screen. Horizontal asymptote is at y equals 2. And then my range, you can write it two different ways if you want to do interval notation, parenthesis 2 to infinity, or you could say y is greater than 2. Sometimes people prefer it that way. Remember, if you have a negative out front, that flips the x-axis, and also remember to flip first. Because if you don't, then you might mess up where it goes because you're having to flip over the asymptote, whereas if you just flip first, you're flipping over 0. Okay, let's look at the logarithmic graphs. So there's one, number 6, 7, 8, 9, 10. I'm just going to go ahead and I'll do number 7. Because that one has a negative, but it's in front of the natural log. So natural logs are the same kind of thing. There is no difference in how you graph it. But remember that the original now goes through 1, 0, and it looks like that. So the transformation here, and you're also going to have a vertical asymptote. So these should all be VA. So go ahead and fix those for 7 through 10. So the transformation here, it's going to be going It's going to flip the x-axis, and it's going to be going right 1. So flip the x-axis, and right 1 means it's going to be going here, and it'll kind of look like this. It's my beautiful picture. And it'll now have a vertical asymptote at x equals 1. My domain would be 1 to infinity. My range is all real, so now the domain and ranges switch. And instead of 1 to infinity for domain, if you prefer, you could say x is greater than 1. But now we're using an x instead of a y, because y is for range. For this section, I think it was 8.3, evaluating logs. These are really short and quick. I know there's a lot of them, but just remembering, okay, how do I get from my base to the number that is next to it? A few of them are the simple identities. So if you ever have a log of 1, that always equals 0. Something that, if you look at number 5, this is one that I can do with you because oftentimes it's one that I see missed a lot. So I have to think, how do I get from 2 to 8? Okay, I raise it to the 3rd power, but it's 1 over 8, so then that is whenever I add a negative. So if it goes from a whole number to a fraction, you're going to have a negative number. Whereas if you have a 2 to a square root of 2, like if it's going from a bigger number to a smaller number, if your base is bigger, then you're going to have a fraction for an answer. So since it's the square root of 2, then my answer would be 1/2. So for all of these, you're just going to go through them and say, how do I get from 2 to 8? How do I get from 2 to 16? What power? It's not what do I multiply it by, it's what power do I raise it to. And then for ones that you're getting smaller, like 13, trying to see if there's any other ones, 14, I think that's all I see. Like those, if you're going from a bigger number to a smaller number, remember that they're fractions. If you're going from a number to a fraction, then that's a negative number. The properties of logs, this was the last thing that you guys did, the 8.4. So we're going to combine our knowledge from that, what you just learned, like condensing, and then also evaluating. So all of these are separated by plus signs or minus signs. If you see a plus sign, then what you're going to do is you're going to multiply the numbers inside. So I have log 50 and log 2, and they're separated by a plus sign. So I could write this as log of 100. And I want you to get number answers for all of these. So we're not completely done, but this is kind of way back when, but when you don't have a base for a log, it is an understood 10. I hope you said that out loud. I hope you just finished my sentence for me. So then from there, I think, how do I get from 10 to 100? I have to square it, so my answer is 2. If we look at number 2, I have a minus sign, so I'm going to say log of 2 divided by 200, which is the same thing as log of 1 over 100. And I don't have a base, so it's an understood 10. To get from 10 to 1 over 100, I would raise it to the negative 2 power. Because not only is it getting squared, but it's also a fraction, a 1 over. So for the rest of these, you're just either multiplying or dividing, but I want you to get numerical answers for these. You shouldn't have a log in your answer, so all numerical answers. I want you to actually evaluate them once you've condensed them. And then for expand and condense, since you guys just watched a video on that, I'm not going to go over that again. But like I said, And I'm going to reiterate again, if you guys have any questions, email me with specific numbers, and then I will make a video and send them out to you. I'm still working with the idea of holding office hours on Zoom, so I'm still going to play with that today, but I just cannot stress enough that you need to communicate, because we are here to help, and I'm here to help all day. So please, please, please just let me know. Y'all have a great day.